power system of design number 1. So this is our FMEA, and as you can see, pretty much the only 3 things that we're super worried about are the shaft, chain, and gear. The handle and the flywheel, they're both thick steel, not super worried about them breaking. And then the chain is the only one that's likely to cause like actual injury when it breaks, just because it'll be outside of our frame and everything. So if it snaps, and if it snaps aggressively, then we could have some injuries there. Other than that, we're not super worried about anything. And then we are redesigning the chain. We're looking at some options to cover it up, maybe have just like a plastic shield, and then that would eliminate the danger of causing injury.
So this is our old design, and we decided to improve upon it because it was super heavy and made it expensive. So we decided to shave down the flywheel part of it.
And this is an overview of our beta design. Next slide. So for our beta design, key thing was once we understood the budget, cost-saving practices became a priority. So the biggest thing with that was material reduction, and for us, scrapping the flywheels and going to having just 2 gears on one side and a lever arm with a handle on the other presented a lot of savings. The other was, instead of having an axle with a key along the entire length, we now have an axle with the keyway cut out at just a select length on either end for the components to attach to. And then for fixing the components to the axle, we use pins on either end. And the gears here, we have 2 sprockets, if you will, and they have a key there to fit in the keyway. They're separated by a cylindrical metal partition, and so one gear would attach bike chain to the bike, where power would be driven, and then the other gear would then attach to a gear on the crushing assembly, and that would then deliver power to another axle that would work the mechanism. And that's here where our beta design is inserted into the frame. On this side you can see the 2 sprockets, so the bike chain would come off of here, go to the bike, and then here and here, these 2 would be attached by another chain.
So there's just a video demonstrating how the assembly is going to work. Here's our attachment from the 1 sprocket to the Jaws Team sprocket up top. So for our FEA, we kind of focused on some critical areas that were identified in the FMEA. So one area that we checked out was going to be the key for the lever arm, because we know that all the loads, the torque that you're going to input is going to be concentrated on this point, because that's what's going to transmit onto the shaft. So we found that the largest load that a human could possibly exert was probably around 700 newtons on that handle. So we put that load onto the handle up top and fixed the key there, and then found that our factor of safety would be above 2 at all spots. We found the largest stress would be about 2 megapascals on that, and it was located around the keyway. And the max displacement was, I believe, right around 3 to the -3 millimeters. So it looks really good, and it should the key design should hold up to any kind of stress that comes up, can be applied to it. And then the other one we wanted to check was our dia for the handle would be to use just a simple bolt that passes through here, and then a nut on the other end. So we wanted to make sure that that would also, so if the shaft locked up because there was a big rock in the jaws or something, and you were still exerting that 700 newtons, we checked that wouldn't break the bolt or anything. So we had the maximum stress was about 1.6 megapascals, and the maximum displacement was about 8 to the -3 millimeters. So again, we had a factor of safety above 2 over the whole assembly. And we don't have on this PowerPoint the FEA for our shaft, but we completed that on the paper. We also found a factor of safety over 2. I believe I did a hand calculation for the shaft to find the minimum diameter should be around 1 inch, and I think we went with about 1.5 for the actual shaft just to keep it safe. And so yeah, everything that we have so far looks like it should be able to hold any loads that can be thrown at it. So that is our presentation.
So how strong is your chain? Did you do any calculation?
We
Will
have
it
not
last?
because we haven't identified what our chain would be yet.
Okay.
We
Yeah.
have looked up what the kind of standard holding force of a bike chain is, and it looks like it'll be plenty fine, something to the tune of like 700 kilograms off the top of my head. And these, in this case, if someone is able to pedal a bike, it should be around the same, maybe a little more impact loading, but in general, if it can withstand staying on the bike, it should be able to withstand powering our system as well.
Okay.
Yeah, so that'll be coming in the future once we actually have what kind of chain we're going to be using. Yeah.
So what's the power input you're looking at for hand cranking and using a bicycle?
How do you mean, like the force
The
input?
power input in the whole system.
Well, we said 700 for the hands. I guess 700 newtons would be the power input for the hand cranking. And
That's a force exerting on it.
Yeah.
Like we're more interested in the power, so we can calculate the fatigue.
The
Oh,
efficiency.
there. Okay.
Yeah, we're still working on,
Yeah.
especially with like gearing, because we haven't determined with the crushing team what the gearing is going to look like, and so that'll need to come later. Just because if we have a small gear and they have a really large gear, or vice versa, that's really going to affect how much power is transferred and how efficiently.
So are you guys scrapping the bike idea? You're just gonna handle?
We still have it.
Yeah, we still have both.
We're including that's what that second sprocket gear on that assembly's for, because one goes to the actual crushing mechanism, and then we have that extra one that you can hook up to the bike. So, yeah.
So how do you manufacture the key lever?
On which part? On the
Go back.
for the lever arm or for the
Right.
here?
Jeez.
Those guys?
Right.
They'd probably be milled out of the sprocket gear. They have. I looked on McMaster Car, and they sell sprocket gears, and they have ones with the same pitch for bike gear, bike chain. If we did want to use a standard bike chain, and they make them so that the diameter you can mill them out. So they'll be you can mill them down to like it'll come with a center hole that's like an inch, and you can mill it down to 2 inches. So we would be able to probably mill in that key there.
We've also discussed an alternative design where instead of the sprockets being keyed, the partition
the
connecting
shaft,
them
yeah.
would be keyed instead.
So the gear will.
Yeah, we
doesn't
might
need to
we
be
might do
keyed,
that
right?
because
I mean, otherwise it's
stresses would
not
probably
easy
be less.
to make that key.
Mhm.
So another, I mean, one consideration similar to for Team6, just like how do you make sure like someone's running these machine can do this for a day or something? Look into that.
Yeah, that
Okay.
especially once we figure out gearing, figuring out how much power they're going to need to put in
Yeah,
to
Right.
keep it
Actually
maintaining.
crush the rocks.
Right. Yeah.
And that's one advantage of the flywheel is the problem with doing some sort of like pushing crush is that you have to exert all of the power in one bit, whereas this you can kind of store it up over time, and humans tend to do a lot better when we have
With like
spread out.
continuous motion.
Because they'll have that with the mass movement, so they'll have the momentum.
Good question.
Yeah, so the key right here, it's actually part of that part.
So we mentioned just now that we're considering bringing it away from the gears and having it just be part of the
It would
shaft.
be in the.
Well, I mean, that will have this key or is that part of that part? Or is it a separate key?
The shaft that they're
Right now, it's a
connecting
part
to.
of it.
Yeah, like when you actually go to make that, you basically slot out that area, and then you have like a more like square key that just sticks there.
Could be
You
so.
can't really actually machine something like that, because you have to have like a really sharp corner.
Yeah. Yeah, that's definitely an option.
Okay.